One of the things that's often done in a course like this is to focus especially on ionic compounds. When we talked about ionic compounds, heavy metal, and how do we write the formula of an ionic compound, and how do we name that ionic compound, called nomenclature. So that's what we're going to tackle next. Now, with regard to ions, ions can be made up of only one atom, and we've talked about those, where an electron is transferred from a metal to a nonmetal. The metal becomes positively charged, and the nonmetal becomes negatively charged. Those are what we call I still think that's monoatomic. I think I'm missing an O. I'm not sure. Monoatomic ions. The other type of ions we're going to talk about are those polyatomic ions, and I think I gave you an example of NO3 nitrate, NO3 minus nitrate. This is actually a set of 4 atoms running around that has an extra electron, so it's -1. What this at the bottom says in italics is anytime you see a cation or an anion, positively charged cation or negatively charged anion, all that means is that there are an unequal number of protons and electrons in that atom if it's monoatomic, or in that set of atoms if it's polyatomic. So it makes it charged. These are the ones I remember I said in the previous part where you can hang your hat on these. Hang your hat. Okay? Which simply means we know what these monoatomic ions, what they form. The group 1A elements, the group 2A elements, not just any elements, they're metals. These metals actually lose 1 electron and lose 2 electrons respectively to form a +1 and +2 cation. These here, the 3A metals, so it's under the jag beginning with aluminum, these lose 3 electrons and form a +3 cation. And then I usually kind of start 7A, pick up 1 electron, okay, hopefully this is ringing some bells, become a -1 charge, okay, the 6A, pick up 2 electrons, become a -2, 5A, pick up 3 electrons, become -3. So I think I might have mentioned that sometimes students on this test will go ahead and they'll put a +1 here, meaning that's the charge, these form, +2, these form, a +3, okay, and then they'll find -1 over the halogens, -2 over the 6A, and -3 over the 5A metals. You can hang your hat on those. Now we're going to actually, in this part, focus also on those ones you can't hang your hat on. Remember, we saw iron can actually have 2 cationic forms. But now I've got an exercise here to I'm not sure which ones you have or which ones you don't have. So sodium forms what charge? +1, it's 1A. Oxygen, it's a 6A, so it picks up 2 electrons, -2. Bromine, it's one of the halogens, 7A, picks up 1 electron, forms a -1. Magnesium, it's a 2A, it loses its 2 valence electrons, becomes a +2. Nitrogen, it's a 5A, it picks up 3 electrons, forms a -3. Potassium, 1A, it's under sodium. Loses its valence electron, forms a +1 cation. Sulfur, it's under oxygen, 6A. It picks up 2 electrons, forms a -2. Fluorine, another halogen, picks up 1 electron, forms a -1. Those halogens are 7A. Ooh, it's not going to go forward. Come on, it's catching up. There we go. Calcium, it's a 2A, loses its 2 valence electron, forms a +2. And last but not least, phosphorus, 5A. To get an octet, it needs 3 more electrons with the 5 it's got. So in picking up 3 electrons, it forms a -3. So these, you should be able just to look at the periodic table, find where they are on the periodic table, and know what ion they form.